Good evening, everybody. Good to see you all here. We're slowly growing. My name is Martin, and today we're going to be speaking about Canary monitoring in services-oriented architectures. Actually, it was really difficult to find a title for this talk because what it really is, it's essentially a journey from a simple system to a very complex one. It's a journey which probably most of the people in this room already went through in their career, and it's really focused on quality. Because that's really what software is all about. We want something that doesn't have bugs, that works, that we can easily monitor, and we have a smooth process to spec things out and develop things. So, little introduction. As Ben said, I work at Tide, and you know, it's not the washing powder. So we got asked this question a few times in previous meetups. So no, it's not that. Fortunately, it's an online account. It's for businesses, and it's pretty cool. And the thing that allows me to speak here to you tonight is essentially, as most of the banking softwares, we essentially run a service-oriented architecture. Now, the reason I say this is that the services are not really micro, but it's essentially the same thing in some ways. So the reason why we split the backend in multiple services, again, is one of the many ways to ensure quality, because in an infrastructure like ours, monoliths don't really work anymore. But it all begins with this. This was essentially my start, my career start. I was working alone. Maybe that's happened to some of you too. And things are all easy. Everything works. You write your own code. Who needs tests anyway, right? You can test it yourself. If you change things, you know what side effects it has. You can kind of retest the things you know could potentially break. But then the natural evolution is something like this. We got multiple developers, actually multiple teams, and in every team we got QAs, product owners. So this is the ideal. Product owner specs out, developers develop, QA tests, and then there we go into production, and everybody's happy. But that's too nice to be true. I mean, that is a happy face, but it's really a troll face, because the harsh reality is something like this. So if you're asking, what is going on? Let me walk you through. And believe me, I've seen this happen quite a few times in a few places. So the product owner specs out. Developers start asking questions because some of the things are not clear. Maybe halfway through, things turned out didn't work as planned. Whatever it is, things go back to a product owner, a little bit of re-speccing, moving things around, back to development. Now development is finished and we go to QA. Obviously, what happens when we go to QA? Bugs are found, so back to developers. We fix the bugs, but if we don't evolve from that initial system we had, like we don't have unit tests, for example, you know, this happens, we go to QA, and by fixing the bugs, we actually broke things again. So back to development again. Things are re-fixed. Now everything looks good. So we go to the product owner. We did it. And this is my favorite part. This is the part where the product owner tells you, this is not what I asked for. So back to development, back to QA. Obviously, we will have broken things again. So back to development, and it's really an infinite cycle. Releases can take weeks or months, and yeah, I did see that happen. So, you know, welcome to the magic world of software engineering. That's how things can be sometimes, but we kind of want to find a way to get back to at least as close as possible to this ideal. So there are many ways to achieve this essentially, and it's not the main topic today. So just to cover a few, we really need to get the test coverage. It doesn't have to be TDD, but at least some sane test coverage. We can even pump it up to behavior-driven development, so that solves a few problems. We can use that as an operational procedure or just a better way of, you know, speccing out our unit tests, given when then. We can use agile methodologies that would avoid massive headaches with going back to the product owners for questions if you do your sprint planning right and all the ceremonies. You can even do continuous integration that will make the whole pipeline to deployment much easier. If you are brave, you can do continuous deployment. Good luck with that. There's still one little problem. That is a problem. So right now, we definitely enhance the quality of our process, but that's still monolith. So when things are small, we're all happy, we're kind of in the ideal zone still, but when a monolith grows, this happens. Yeah? If you go above 500 lines of code in a single project, you kind of feel like that. Obviously, if you got good devs, you modularize things, you got a nice architecture, all right. But you know, there is a limit. You will get some annoying things happening. Essentially, we'll have slow startup. It makes it hard to test manually and automatically because you keep spinning up things for taking 1-2 minutes. Release management becomes a nightmare. Multiple things happening at the same time. Lots of teams working on the same project. Subtle changes, unwanted side effects. Lots of pressure on a single data store. And so on. So we could move to microservices, and if we do it, we need to do it right. So it needs to be a shared nothing architecture. Don't share a single database with like 50 microservices. That's not how it's meant to be. You need strong contracts to communicate between them. Maybe even doesn't have to be a synchronous API. It could be something event-driven. You know, you could embrace eventual consistency when possible and required. Obviously use a service discovery system or a service bus. So now we're kind of back to the ideal. We got our services or microservices over there. And then, you know, things grow, the company grows, we're happy, right? We got more services. So what happens next? What can possibly go wrong again? How can we destroy this? This happens. So then you get overwhelmed. And it's actually a nice problem to have. And usually if you get to that stage, and you're not Facebook size, probably you need to rethink a few things. So it's not really a common use case to get to that scale, like having hundreds or thousands of microservices. So Google, yeah, Twitter, Amazon, Netflix, these are all companies that we know from their tech talks, blogs, that they have that kind of scale and that they use microservices every day in production. So how can we deal with such scale? And this is where things start getting interesting. There are many ways, obviously, but I chose these 4 because they're kind of relevant to our favorite technology, hopefully in this room, the JVM. Reason being, chaos engineering and intuition engineering, it's something that Netflix kind of invented, and they heavily use Java. Canary releases. Again, this is not something Netflix invented, but I got a few nice examples from their blog. And Canary monitoring, this is something that, if you Google this, it's not easy to find a definition, but we'll get to that later. So if we pick as an example chaos engineering, what it is essentially, and it can in a way be also defined as Canary monitoring. You formulate a hypothesis and you embrace the fact that you have a chaotic system, which is having 1,000 microservices, which is kind of what Netflix has. The reason why we call it chaos is because at that scale, all the best practices we had, probably what we in this room do, all our nice pipelines, our processes, having some manual QA and staging before pushing to production, all just goes in the bin. You just can't do that anymore when you get to that scale, to their scale. Because once you have thousands of microservices, there's no chance whatsoever that you can have a staging environment which is similar enough to your production environment. You cannot run regression tests, too many features to test. You cannot really do any manual QA in any sensible way. So it's really up to the developers, and these companies are the ones which heavily focus also on DevOps and automation and all the useful stuff to deal with that chaos. So what do? They kind of invented the Siemens army, which is a set of tools that produce controlled chaos in their production environment. So you formulate a hypothesis. Say my hypothesis is my services don't go down if I randomly switch off a server because they are all redundant and behind very smart load balancers. So you can run a controlled experiment, maybe in just one data center. Obviously Netflix has quite a few around the world on AWS. Maybe just for a certain population, like in Denmark. And it's very controlled. It's not like let's drop a bomb in production and see what happens. So then you measure the effects. So you take the metrics. Obviously, it needs to be a very advanced system, and see if things are still going well effectively. If things did go well, then the hypothesis is confirmed. If not, you need to fix things. This is essentially an exercise to make the system more resilient. And then you automate it. It needs to run continuously. They really do this. They have, I think it's this thingy over here, it's the Chaos Monkey that randomly switches of terminates EC2 instances in their AWS regions during day hours. Another thing they invented, which is really cool, Netflix again, Visual. This is the concept of intuition engineering. You can find a very nice talk on YouTube from Casey Rosenthal. Essentially, the idea is that you want to monitor things and present them in a way to the engineers that the human brain can kind of understand, because it's really visual, it's very peculiar. I will show you a video. And then your brain gets a sense of what is normal in your infrastructure, how are requests flowing through, what latency, what volumes, and you can easily spot from your office, from your monitoring dashboard, if something is different, and that's why it's called intuition engineering. So this is an example, this is a video I took from YouTube from one of their talks. Essentially, the central circle represents, this is visual, the central circle represents the internet. That's traffic from the internet flowing to different AWS regions. So the blue dots, let me play this. The blue dots represent HTTP requests. The red ones are unsuccessful requests, say 500 errors. The speed at which they go, that's the latency. And what they're doing here, essentially, you might notice the 7, 8, 9% error rate in the US West region. Maybe they deployed something, maybe something in this infrastructure is wrong. So what they do, because they're smart, unfortunately they have proxies everywhere. So they are essentially taking their proxy in US West 2, bring all the traffic to US East 1. So that's what's currently happening. Obviously that cannot happen like as a switch. You need to give time to US East 1 to autoscale, and now it's kind of able to take a load of traffic. As you can see, there are far more dots going over. And once we're sure that it's all fine, it can take the load, there is a DNS flip, and now all the traffic is going that direction. And now the engineers have time to kind of go into US West 2 and figure out what's going wrong, fix the problem, and then switch DNS again. That should happen now, yeah. The proxy obviously is still sending stuff through to the other data center, and it will be switched off at one point. And this is where operations resume normally again. And this is a super cool tool. You can actually then click on these data centers, because all the metrics are actually coming from their microservices. So this is what it looks like. And we actually started playing around with this at Tide. It's really interesting. Essentially, you need a heartbeat. You need to aggregate those metrics and send them like every second or so to Visual, and it will build this very nice visualization. It's a very simple Node.js and web application, HTML and JavaScript. Okay, so this is the hot topic today, which is Canary releases and Canary monitoring. Why the term Canary, first of all? Well, a couple of 100 years ago, the miners would go into coal mines, and there was a risk of having poisonous gases down there, but it's not like you can smell them. So it's very dangerous, essentially. They brought canaries down because they were far more sensitive to this, and they would like die within a few minutes, sorry, it's a bit harsh. Giving time to the miners to run away and go back to surface before anything nasty happens to them. So essentially what it is, it's something that keeps you safe. So this term, Canary monitoring, which I must admit I almost invented, it essentially means any kind of advanced monitoring that keeps you safe from having things go really wrong in production. And this is Martin Fowler's definition of a canary release, which is one of the techniques that we can use in a large, complex system to stay safe. Again, example from Netflix. This is from their blog. This is how their deployment pipeline looks like. So they have unit tests, regression tests, and then there is this very nice canary analysis phase. So what it is, again, I can't have any certainty that whatever I have in staging is going to work. So what they do is I think they still use nowadays Spinnaker, which is kind of a mixture between, you can imagine that as Jenkins plus something that deploys stuff in a very complex way into production, allowing you to do blue-green deployments. Well, they call them red-black Canary deployments and other interesting things. So what the Canary analysis does is essentially they direct like 1% of the traffic in production to the a small cluster with all the new services that they want to release to production. And essentially, because they have very advanced metrics, they can compare the metrics between the baseline, the current production environment taking 99% of the traffic, and the Canary environment, which is taking 1%. And they decided whatever is under 90% is a fail. So again, this is an example of a release that didn't go too well, because now we have like 25% more errors, 500 errors in our Canary environment. So it's still not ready to be pushed to production. So back to the devs essentially and figure out what's going on. Canary endpoints, this is something slightly different. Everybody in this room must have heard about health endpoints, but it's something really simplistic. It's essentially just, am I up or down? It's something typically load balancers use to determine whatever is behind them if they should just not send requests in that direction anymore. So while I was working at Tide, I actually figured out we want something more complex than that. It's not as easy as up and down. I mean, my service will definitely be down if its central, if its main data store, the database, say MySQL, is not responding. But there might be some conditions where I'm maybe degraded, but not really down. So we want to really collect more sophisticated information about the desired state of the system. So we can have a Canary endpoint on every one of our services or microservices. I think if you Google Canary endpoint, this is not really my invention. It's something that exists. And I tend to think about it like something that gives you more advanced metrics than a simple health point, something that can really save you from issues in production. So we got this imaginary payment service. Like, say we are building a new feature at Tide where we have to support all kind of international payments, and we are integrating into a payment processor. We have everything set up in staging, but obviously the credentials in production will be different. So when we release to production, we just want to know it works. We don't want to wait for the first customer to hit the payment endpoint, try and make a payment, and it doesn't work because whatever credentials we have or certificate to communicate with the payment processor doesn't work. Other things that might happen, we have a fees page, which is really just a web view on the app because we want to be able to change it easily and not hard-code it somewhere in the native iOS or Android app. So there will be this link to a web view, but did we remember to upload it into our production environment? Because obviously we know it works in test and staging, right? But who knows about production? And once we are in production, I mean, are the data sources available? We have a database. Unfortunately, banking providers, they're like super boring, old technologies, so they end up using FTP for receiving payments. It's ridiculous, but that's how it is. Are there any pending payments in our pipeline that need to be processed by our scheduled tasks? Are the fees set up correctly in the database? Because maybe they're different, again, from our test environment. Did we remember to put the fees before deploying to production? Or did we delete them by mistake with a migration or a sysadmin in production? So every single thing is something that might be wrong in production and you will never catch with a unit test, and maybe not even with QA on staging. So this is actually going into the state of the system, figuring out what are all the dependencies of your service and essentially monitoring them. Then I figured out, okay, once I collect all these metrics on the Canary endpoint, we say we have a queue, that's the incoming MasterCard transactions. It's just an example, that's not how Tide really works. We have a worker that needs to run every 5 minutes for the pending payments. We have some storage where we save attachments when you upload an attachment for your transaction. We have a database and so on. So then I figured out what this is. These are all dependencies of our service. But maybe these dependencies are dependencies of other services. And actually my service depends on other services and other services depend on my service. So I kind of thought, this is a graph, okay? And if I aggregate all the metrics from the different Canary endpoints in our infrastructure, now we can get to something interesting. Again, we can visualize easily without having to use any fancy tools our whole infrastructure. And when things go wrong, our Canary endpoint will tell, whoops, the FTP isn't working anymore, or at least right now. So it will become red, for example. I'm currently building a tool to do that. And we might even get emails if something goes wrong. So it's actually like Visual, a very cool way to visualize what's going wrong and what is actually working in your infrastructure. Unfortunately, as everything that happens in my free time, being a team lead in a very busy startup, I just don't have time to finish it off. So there are a few projects out there in my GitHub, but they're kind of incomplete. The Canary thing, that's a plugin for Spring Boot that can essentially expose all these advanced metrics in a it's an HTTP response, it's JSON. Graph Canary is that fancy thing that then aggregates from multiple services. But I can actually show that to you because it's here in a very experimental way. It's this guy. This is a fake infrastructure, so I just call them API 1, 2, and 3. As you can see, these services, need to communicate with each other, and then each one has its own database and some dependencies, and some of the dependencies like this worker and this message channel are actually a dependency of like API 1 and API 2. And then you can switch between visualizations. Maybe you're only interested in knowing what are the dependencies of this guy, and you can filter out. And you can even choose a less hierarchical view. When things become more complex, you can switch to something like this, move things around a little bit, zoom in, zoom out. And yeah, that's pretty much it. So this is what I call Canary monitoring, which again doesn't really exist as an official definition, so you won't find it on Google. That's it.